The telegram arrived at Henry Kaiser's Oakland office on a fog-shrouded morning in December 1940. Inside, the message from President Franklin Roosevelt carried the weight of a nation's survival. Amir Ike needed 10,000 cargo ships, and they needed them yesterday. Kaiser read the words twice, set down his coffee, and did something that would have seemed insane to any rational businessman. He smiled. Across the Atlantic, Hitler's U-boats were winning. Every day, German submarines sent Allied cargo vessels to the ocean floor faster than American shipyards could replace them. The mathematics of defeat were brutally simple. Traditional shipbuilding took 230 days per vessel. At that rate, the Allies would run out of ships before they ran out of war. The British Maritime Commission had already calculated the grim timeline. Without a miracle in manufacturing, the Atlantic supply line would collapse by late 1942, and with it, any hope of defeating Nazi Germany. Henry Kaiser was not a shipbuilder. He had never constructed a vessel in his life. He was a dam builder, a road paver, a man who moved mountains of concrete and earth across the American West. His critics, and there were legions of them in the established shipbuilding fraternity, called him a glorified gravel hauler. The Portland Shipbuilding Association publicly declared that Kaiser's appointment to lead the Liberty Ship program was an insult to naval architecture. Traditional shipwrights, whose families had been building vessels for generations, sneered at the notion that this upstart civilian could revolutionize an industry that had remained fundamentally unchanged since the age of wooden sailing ships. But Kaiser understood something the shipbuilders did not. Ships were not sacred relics to be handcrafted by artisan guilds. They were industrial products, and like any industrial product, they could be mass-produced. According to a detailed analysis published in the Baltimore Sun in April 1940, 1. Kaiser's radical proposal involved treating ship construction like automobile assembly, breaking the process into standardized, prefabricated sections that could be welded together rather than riveted. The established maritime industry regarded welding with deep suspicion. It was considered inferior to the time-honored riveting technique that had built the Titanic and every great vessel before it. Kaiser arrived at the Richmond shipyards in California with a vision that horrified maritime traditionalists. Where they saw ships as individual masterpieces requiring months of skilled craftsmanship, he saw an assembly line. Where they insisted on riveting 10,000 metal plates together by hand, he proposed welding prefabricated sections. Where they trained workers for years before allowing them near a hull, he promised to train civilians in weeks. The old guard predicted catastrophic failure. Ships would crack apart at sea, they warned. Welds would fail in cold Atlantic waters. The whole program would become a floating graveyard. What neither Kaiser nor his critics fully grasped in those early days was that they were about to witness the birth of modern industrial warfare, a contest that would be won not by the side with the best soldiers, but by the side that could manufacture faster than the enemy could destroy. On the morning of April 14, 1941, a woman named Margaret Hill walked through the gates of Richmond Shipyard No. 2, carrying a lunch pail her husband had used in his construction job before enlisting. She was 32 years old, had never held a welding torch, and had spent the previous decade raising 3 children. Within 6 weeks, she would be supervising a crew of 15 welders building the hull sections of Liberty ships. Margaret was not unique. She represented Kaiser's most controversial innovation, replacing skilled maritime craftsmen with ordinary civilians trained in a fraction of the traditional time. The plan outraged union shipbuilders. The International Association of Machinists called it a dangerous dilution of skilled labor that will cost American lives. Yet Kaiser persisted, establishing training programs that condensed years of apprenticeship into 4 to 6 weeks of intensive specialized instruction. Workers learned one specific task, welding a particular seam, installing a certain pipe configuration, bolting together predetermined hull sections, and learned it to perfection. Kaiser's real genius lay not in speed, but in reimagining the entire manufacturing philosophy. Traditional shipyards built vessels sequentially, from keel to deck, with each stage dependent on completing the previous one. Workers stood around waiting for colleagues to finish their sections before beginning their own tasks. Kaiser looked at this medieval approach with the eyes of a dam builder who had coordinated thousands of workers pouring concrete simultaneously at the Hoover Dam. According to records preserved in the National Archives and referenced in maritime historian John Gorley Bunker's 1972 book Liberty Ships, The Ugly Ducklings of World War II, Kaiser divided Liberty ship construction into prefabricated modules that could be built simultaneously in different locations. The Richmond shipyards became a choreographed industrial ballet. In one area, teams assembled bow sections. In another, stern sections took shape. Engine rooms were constructed as complete units. Hull plates were welded into massive panels in covered sheds, protected from weather delays that had plagued traditional open-air construction. When all sections reached completion, massive cranes, some of the largest in the world, lifted these multi-ton modules and lowered them onto the ship's keel like pieces of an enormous jigsaw puzzle. What had taken months now took days. The welding decision proved transformative. Traditional riveting required teams of skilled workers heating rivets, tossing them to catchers, and hammering them into place. A process that joined two plates with thousands of individual fasteners. Welding fused plates together in continuous seams, reducing labor time by 70% and creating stronger joints that distributed stress more evenly. Despite the old guard's dire predictions, welded Liberty ships proved more durable than their riveted predecessors, flexing with ocean swells rather than cracking at rigid rivet points. By September 1941, Kaiser's methods had reduced construction time to 105 days per ship. Still not fast enough, but improving. Then he implemented the final piece of his industrial revolution, 24-hour operations with 3 shifts of workers maintaining continuous production. The photograph that appeared in Life magazine on November 22, 1942, showed something that defied belief. A completed Liberty ship, the SS Robert E. Peary, floating proudly in Richmond Bay just 4 days and 15 hours after workers had laid its keel. The image circulated through Allied command posts, Nazi intelligence offices, and neutral newspapers worldwide with the force of a propaganda bomb. 4 days. Impossible, the experts said. A publicity stunt, claimed German High Command. A fraud, insisted traditional shipbuilders. It was completely real. The Robert E. Peary construction represented the culmination of Kaiser's assembly line philosophy, operating at theoretical perfection. Every innovation converged. Prefabricated sections had been built weeks in advance during quiet periods, creating a stockpile ready for rapid assembly. Workers had rehearsed their roles like actors preparing for a performance, eliminating wasted motion and confusion. Supply chains delivered materials with clockwork precision. The 24-hour shifts maintained relentless momentum. Most crucially, Kaiser had gambled everything on this single attempt, pulling resources from other projects to demonstrate what his system could achieve when operating without constraints. The actual sustainable production rate stabilized at approximately 42 days per ship, far short of the 4-day record, but astronomically faster than the 230-day traditional timeline. By late 1942, Kaiser's Richmond yards were launching 3 ships simultaneously on some days. The production numbers told a story that shifted the mathematics of the Atlantic War. In 1941, before Kaiser's methods scaled up, American shipyards produced 112 cargo vessels. In 1943, they produced 1,949. The difference between those numbers represented the margin between Allied victory and defeat. Kaiser's workforce grew to encompass 90,000 workers across his West Coast shipyards. Women constituted nearly 30% of the workforce, an unprecedented figure that challenged every assumption about industrial labor and gender roles. The famous Rosie the Riveter imagery drew direct inspiration from Kaiser's female welders and riveters, who proved equally capable as their male counterparts while shattering social conventions that had restricted women's industrial participation for generations. The Liberty ships themselves were unglamorous vessels. Maritime architects called them ugly, boxy, slow, and aesthetically offensive. They carried 7,000 to 10,000 tons of cargo at 11 knots, barely faster than a person could run. Their welded construction occasionally suffered from brittle fracture in cold North Atlantic waters, and several ships did crack or break apart, validating some traditional shipbuilder concerns. But they served their purpose, delivering tanks, trucks, aircraft, ammunition, food and fuel to Britain and the Soviet Union faster than U-boats could sink them. German Admiral Karl Dönitz, commanding Hitler's submarine fleet, watched the production numbers with growing alarm. His U-boats were sinking Allied ships at a fearsome rate, over 1,000 vessels in 1942 alone. But the mathematics had reversed. According to Dönitz's own post-war testimony at the Nuremberg trials, referenced in historian Clay Blair's Hitler's U-Boat War, by mid-1943 the Allies were launching cargo ships faster than Germany could destroy them. The turning point in the Atlantic War was not a military battle but an industrial one. Not everyone celebrated Kaiser's industrial miracle. On the evening of July 19, 1943, a Liberty ship named the SS John P. Gaines split completely in half while docked at a Portland, Oregon pier. The crack propagated from a welded seam, racing through the ship's hull in seco ends with a sound witnesses described as resembling a massive tree snapping. Fortunately, the ship was unloaded and unmanned. No one died. But the incident, and 17 similar catastrophic failures, gave ammunition to critics who had warned that Kaiser's shortcuts would kill sailors. The fracture problem stemmed from multiple sources. Some welds were poorly executed by inadequately trained workers rushing to meet quotas. The steel itself proved vulnerable to brittle fracture in cold ocean temperatures, a metallurgical phenomenon not fully understood in the 1940s. The continuous welded seams, while generally stronger than riveting, provided pathways for cracks to propagate through entire hull sections, whereas riveted
construction contained fractures to individual plates. Traditional shipbuilders seized on these failures as vindication of their warnings about sacrificing quality for speed. Kaiser responded not with defensiveness, but with scientific rigor. He hired metallurgists, established quality control protocols, modified steel compositions, and implemented crack arrestor designs that prevented fractures from propagating. Workers received additional training. Inspections intensified. The improvements worked. Catastrophic failures decreased dramatically after mid-1943, though never entirely ceased. The calculus remained grim, but practical. Liberty ships were meant to survive several crossings, not decades. If a ship delivered even 2 or 3 cargo loads before succumbing to U-boats or structural failure, it had succeeded. The human toll extended beyond structural failures. Shipyard accidents killed or injured thousands of workers during the war, according to Department of Labor statistics cited in historian Amy Kesselman's Fleeting Opportunities. Women shipyard workers in Portland and Vancouver. During World War II, West Coast shipyards recorded over 150 fatalities and tens of thousands of injuries between 1941 and 1945. Workers fell from scaffolding, were crushed by equipment, burned by welding accidents, or struck by falling materials. The relentless production pressure created an environment where safety sometimes took second place to speed. Margaret Hill, the housewife-turned-supervisor introduced earlier, lost 2 fingers to a welding accident in January 1944. She returned to work 6 weeks later, learning to weld left-handed. When asked decades later why she continued despite the danger, she offered a response that captured the wartime mentality. "My brother was on a destroyer somewhere in the Pacific. Every ship we finished might be the one that kept him supplied, kept him alive. You didn't think about your fingers. You thought about that." The pressure affected everyone differently. Some workers thrived in the intensity, driven by patriotic purpose and unprecedented economic opportunity. Many women earned higher wages than they had ever imagined possible, achieving financial independence that would reshape post-war expectations about women's economic roles. African American workers found opportunities in Kaiser's shipyards that had been denied them in traditional industries, though they still faced discrimination and segregation within the yards themselves. Kaiser established integrated work crews and non-discriminatory hiring practices that were progressive by 1940s standards, though far from perfect by contemporary measures. Others crumbled under the strain. Alcoholism increased. Marriages strained under the pressure of both spouses working exhausting shifts. Children grew up in hastily constructed housing projects with minimal supervision. In a nondescript office building in Washington, D.C., a team of analysts worked through the night of March 15, 1943, calculating the precise moment when the United States had achieved shipping production superiority over the Axis powers. The number they arrived at was both thrilling and sobering. American shipyards were now producing cargo capacity faster than German, Italian, and Japanese forces combined could destroy it. The tipping point had occurred in February, and few outside military planning circles recognized its significance. This was statistical warfare, victory determined not by tactical genius or battlefield heroics, but by industrial mathematics. The U-boat war had been, from its inception, a contest of tonnage sunk versus tonnage built. German Admiral Dönitz calculated that sinking 700,000 tons of Allied shipping monthly would strangle Britain's supply lines and force surrender. Through the dark days of 1942, his submarines approached this goal, sending 6 million tons to the ocean floor. The Allies appeared to be losing a war of arithmetic. Kaiser's Liberty ships rewrote the equation. In 1943 alone, American shipyards launched over 19 million tons of new shipping, more than 3 times what the Axis sank that year across all theaters. The U-boats continued hunting, continued killing, but they were fighting against an industrial tsunami. Every 3 Allied ships sunk were replaced by 5 new ones. The ratio shifted the war's trajectory more decisively than any single military engagement. The production metrics revealed the scale of Kaiser's achievement. Between 1941 and 1945, American shipyards produced 2,710 Liberty ships, an average of nearly 2 per day at peak production. Add in other vessel types, and American yards launched over 5,000 large cargo ships during the war years. This represented roughly 70% of all Allied merchant shipping constructed during the conflict. British shipyards, devastated by bombing and resource constraints, produced a fraction of this total despite their longer maritime heritage. The economic impact proved equally transformative. Kaiser's contracts exceeded $5 billion, an astronomical sum equivalent to over $90 billion in 2025 purchasing power. This capital flowed through the American economy, employing hundreds of thousands of workers, supporting steel mills, engine manufacturers, and countless suppliers. The West Coast experienced an economic boom that reshaped the region's demographic and industrial landscape. Cities like Richmond, California, exploded from populations of 23,000 in 1940 to over 100,000 by 1943, creating instant urban centers around the shipyards. The strategic implications extended beyond raw tonnage. Liberty ships enabled Allied operations that would have been logistically impossible otherwise. The D-Day invasion of Normandy on June 6, 1944, required transporting 150,000 troops and their equipment across the English Channel, supported by a supply chain stretching back to American ports. Without Liberty ships maintaining that supply line, the invasion could not have been sustained. The same held true for operations in the Pacific, North Africa, and Italy. Every Allied offensive rested on a foundation of merchant ships delivering fuel, ammunition, food, and reinforcements. According to detailed shipping records preserved by the U.S. Maritime Commission and analyzed in historian L.A. Sawyer and W.H. Mitchell's The Liberty Ships, these vessels carried approximately 75% of all cargo shipped overseas during the war years. They transported everything from tanks and aircraft to prefabricated buildings, locomotives, and mail. Captain Michael Torres stood on the bridge of the SS Jeremiah O'Brien as she cleared San Francisco Bay on her maiden voyage, March 10, 1943, and felt the Liberty ship's distinctive shudder as her single screw pushed against Pacific swells. Around him, merchant mariners, many on their first voyage, worked with a mixture of determination and barely concealed terror. They knew the statistics. 1 in 26 merchant mariners would die during the war, giving the U.S. Merchant Marine a higher casualty rate than any military branch except the Marine Corps. Liberty ships earned grudging affection from the men who sailed them, despite their utilitarian design. Crew members called them ugly ducklings, Kaiser coffins, and less printable names, yet came to appreciate their sturdy reliability. The ships handled rough seas better than their boxy appearance suggested. Their simple design meant repairs could be made at almost any port. Most importantly, they kept floating even after sustaining damage that would have sunk more sophisticated vessels. Captain Torres's first voyage took the Jeremiah O'Brien to Brisbane, Australia, loaded with aircraft parts, ammunition, and medical supplies. The journey consumed 47 days, including stops in Pearl Harbor and New Caledonia, and traversed waters where Japanese submarines prowled constantly. Merchant ships traveled in convoys when possible, surrounded by naval escorts, but protection was never guaranteed. On the return voyage, Torres watched from his bridge as a torpedo struck a tanker 2 positions ahead in the convoy. The explosion created a fireball visible for miles. The tanker sank in 11 minutes. Torres counted only 16 survivors from a crew of 42. The psychological toll on merchant mariners rivaled any combat soldier's experience, yet they received none of the recognition. Technically, civilians merchant seamen were not entitled to military benefits, despite sailing into war zones under constant threat. They could not be ordered to sail dangerous routes. Each voyage was theoretically voluntary, though refusing meant loss of employment and social stigma. The pay was good by civilian standards, but came with the knowledge that each convoy might be your last. Life aboard Liberty ships followed strict routines that provided psychological structure amid chaos. Crews typically numbered 40 to 60 men: deck officers, engineers, able seamen, oilers, cooks, radio operators, and armed guard units, Navy personnel manning defensive guns mounted on the ship's deck. The accommodations were Spartan but adequate: small cabins, communal mess halls, and precious little entertainment beyond books, cards, and radio when reception permitted. Voyages to Europe consumed 3 to 4 weeks. Pacific runs could stretch to 2 months. The ships carried defensive armament, typically 1 5-inch gun aft, 1 3-inch gun forward, and 8 20mm anti-aircraft guns. But these provided limited protection against submarines. A Liberty ship's best defense was its convoy, its zigzag course, and luck. When U-boats or aircraft attacked, merchant crews could fight back, but their primary mission was delivering cargo, not combat. Many ships never fired their guns in anger. Others fought desperate battles against submarines and aircraft. Perhaps the most harrowing route was the Murmansk Run, convoys supplying the Soviet Union via Arctic waters north of Norway. German air bases in Norway and submarine packs in the Barents Sea made these convoys extraordinarily dangerous. The infamous PQ-17 convoy in July 1942 lost 24 of 35 merchant ships, including several Liberty ships. Crews endured not just combat, but brutal Arctic conditions, where falling overboard meant death from hypothermia in minutes. In the operations room of U-boat headquarters in Lorient, France, Admiral Carl Dunnett studied the intelligence reports with mounting frustration. The date was November 3, 1943, and the numbers told a story of strategic failure. His submarines had sunk over 300 Allied merchant ships in the past 6 months, a figure that would have been decisive in 1941. But in late 1943, those losses barely dented Allied shipping capacity. American shipyards were launching replacement vessels faster than U-boats could target them. Donitz had pioneered the wolf pack submarine tactics that had nearly won the Battle of the Atlantic. Groups of U-boats would coordinate attacks on convoys, overwhelming escorts.
Through sheer numbers. The strategy proved devastatingly effective through 1942, when U-boats seemed poised to sever the Atlantic lifeline. But by mid-1943, the calculus had shifted. Allied advances in radar, sonar, aircraft coverage, and code-breaking made U-boat operations increasingly suicidal. Submarines that once hunted with impunity now found themselves hunted. The industrial factor proved equally decisive. According to Donitz's own calculations, preserved in German naval archives and referenced in military historian Timothy Mulligan's Neither Sharks Nor Wolves, the men of Nazi Germany's U-boat arm, the Kriegsmarine, needed to sink 800,000 tons of Allied shipping monthly to maintain strategic parity. Even in the U-boat's most successful period, they rarely exceeded 700,000 tons monthly. By late 1943, Allied production was delivering over 1 million tons of new shipping capacity every month. The mathematics were unsustainable. German submariners paid an horrific price attempting to stem the tide. The U-boat service suffered the highest casualty rate of any German military branch. Over 75% of U-boat crew members died during the war. Of approximately 40,000 men who served in U-boats, 30,000 perished, most drowning in their submarines when depth charges or aircraft bombs breached pressure hulls. The average U-boat survived just 3 combat patrols before being destroyed. The submariners developed a bitter respect for Liberty ships, which proved maddeningly difficult to sink completely. The ship's welded construction and compartmentalized design meant they often remained afloat, even after torpedo strikes. U-boat commanders reported instances of Liberty ships limping to port, despite massive hull damage that would have sunk traditional vessels. The ship's lack of valuable military cargo, most carried bulk supplies rather than troops or critical equipment, made them poor targets for precious torpedoes. By May 1943, Dönitz effectively conceded defeat in the Atlantic. He withdrew submarine concentrations from the North Atlantic convoy routes, redeploying them to less defended areas. The decision marked the turning point in the Battle of the Atlantic, though fighting continued until war's end. The strategic failure stemmed partly from Allied technological and tactical improvements, but fundamentally from industrial mathematics. Germany could not build submarines fast enough or sink ships fast enough to overcome American industrial production. The industrial disparity manifested in every dimension of the war. Germany's entire 1943 steel production totaled approximately 30 million tons. The United States produced over 80 million tons that same year. The last Liberty ship, the SS Albert M. Bow, slid down the ways at California Shipbuilding Corporation on September 30, 1945, 27 days after Japan's formal surrender aboard the USS Missouri. By then, the urgency that had driven their construction had evaporated. The war that required 10,000 cargo ships had ended with roughly 2,710 Liberty ships delivered, alongside hundreds of other vessel types. The remaining ships under construction were completed, canceled, or repurposed, but the era of frantic production had concluded. Henry Kaiser emerged from the war as one of America's most celebrated industrialists and one of its wealthiest men. He leveraged his wartime success into peacetime enterprises, founding Kaiser Aluminum, Kaiser Steel, and Kaiser Permanente, the health maintenance organization that began as medical care for shipyard workers and grew into one of America's largest healthcare providers. His reputation as an industrial visionary was secure, though maritime traditionalists never fully forgave his disruption of their ancient craft. The Liberty ships themselves faced an uncertain future. Nearly 200 were sunk during the war by enemy action. Several dozen suffered catastrophic structural failures, but over 2,000 survived, and the question became, what to do with a massive fleet of utilitarian cargo vessels designed for wartime urgency, not peacetime economy? The answers varied. Hundreds were sold to private shipping companies at bargain prices, forming the backbone of post-war commercial maritime commerce. Others were placed in reserve fleets, mothball fleets, harbored in bays and estuaries, maintained in minimal condition for potential future emergency. Many were eventually scrapped as newer, more efficient vessels replaced them. 2 Liberty ships survive today as museum ships, preserved as monuments to the industrial achievement they represent. The SS Jeremiah O'Brien, whose wartime captain was introduced earlier, remains operational in San Francisco, one of only 2 remaining Liberty ships still capable of sailing under her own power. The SS John W. Brown serves as a museum in Baltimore. Both ships offer living connection to the industrial mobilization that transformed America and determined the war's outcome. The Liberty ship program's broader legacy extended far beyond the vessels themselves. Kaiser's innovations in prefabrication, modular construction, and assembly line manufacturing influenced post-war industrial development across numerous sectors. The wartime shipyards demonstrated that massive civilian workforces, including women and minorities largely excluded from heavy industry before the war, could master complex technical work when given proper training and opportunity. Though many women were displaced from industrial jobs when servicemen returned, the precedent had been established, contributing to gradually expanding economic opportunities in subsequent decades. The program validated industrial mass production applied to complex manufactured goods. Before Liberty ships, items like ships, aircraft, and tanks were built in relatively small numbers by skilled craftsmen. The war proved that even sophisticated machinery could be manufactured at scale using standardized components and semi-skilled labor. This principle would reshape post-war manufacturing, from automobiles to electronics. Economically, the Liberty ship program represented one of history's most successful industrial investments. The ships cost approximately $2 million each to construct, equivalent to roughly $35 million in 2025 currency. They delivered cargo worth many times their construction cost and enabled military operations that would have been impossible otherwise. The program employed hundreds of thousands of workers, established industrial infrastructure on the West Coast, and generated expertise that fueled post-war economic growth. Most profoundly, the Liberty ships demonstrated that wars between industrialized nations would be decided not primarily by tactical brilliance or battlefield courage, though both remained essential, but by industrial capacity. The side that could manufacture faster, produce more, and replace losses more quickly would prevail, regardless of military tradition or tactical sophistication. Admiral Donitz's U-boats were superbly designed and skillfully employed, but they could not overcome an adversary producing cargo ships faster than submarines could sink them. This lesson shaped the Cold War strategic calculations that followed. Both the United States and Soviet Union recognized that future conflicts would be won by industrial capacity as much as military capability. The nuclear arms race became partly a contest of who could manufacture more missiles, bombers, and submarines. The collapse of the Soviet Union in 1991 stemmed partly from inability to match American industrial production across multiple domains simultaneously. For Henry Kaiser, the Liberty ships remained his greatest achievement despite his subsequent business successes. In a 1953 interview, reflecting on his career, he returned repeatedly to the wartime shipyards and the ordinary Americans who built vessels on schedules experts had declared impossible. "We proved something important," he said. "When a free people are properly organized and motivated, there's no limit to what they can accomplish." The ships themselves were just steel. The real achievement was showing what Americans could do when their country needed them. The shipyards are largely gone now, replaced by container terminals, warehouses, and waterfront development. The vast workforce dispersed, pursuing peacetime lives. But the Liberty ship's legacy endures, not just in the 2 museum vessels, but in the fundamental demonstration that impossible timelines become achievable when industrial innovation, workforce training, and urgent necessity converge. The civilian who made ships appear every 4 days instead of 230 proved that the limitations we accept are often merely the boundaries of imagination.